Hello students, welcome to this video tutorial on strategies to find linear relations note, part 1. Alright, let's look at the first section. Section A, there's a really big hint here. Use addition or subtraction. So I've got a T-chart here, okay? We've got the value table, we've got the N value, and we've got the A value, okay? So here's the strategy here. I've highlighted it in yellow. What do we do to N to get A? So it's very important that you don't look downwards down this chart here. We're looking for the relationship between N and A. Okay? So if we have an N value, a term value of 0, then and we have an A value of 3, what could we have done to 0 to make it 3? Now remember, let's look at the hint here. What section of the note is this in? Okay, so if you've got an idea of what we had to do to 0 to get 3, then let's see if that rule works for the next value. So if we have an N value of 1, and then we get an A value of 4, does your rule still work? Okay, so let's think back to the strategy here. What do we do to N to get A? So what is it that we did? Okay. So we added 3. If we add 3 to 0, we get 3. If we add 3 to 1, we get 4. And if we add 3 to 2, we get 5. So it's very important that you check your strategy or your rule 3 times. Does it work 3 times? Well, I just checked it with mental math. 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5. Okay, so I know that this strategy of adding 3 to N to get A works. Okay, so let's go to the next section. Describe the rule in words. Okay, so we've had a lot of practice doing this. So what is this? Well, N is a number. Okay, so a number. And then what did we do to that number? So we can describe the rule in a number of ways. Okay, a number increased by 3, a number added to 3, the sum of a number and 3. These are all rules, okay, that would work, right? We're just taking this strategy and we're making it into a math statement. Okay, so now let's complete the value table. So now that we know the rule, a number increased by 3, let's go in and fill out the rest of the value table. Okay, so 3, which is a number, increased by 3 equals 6. Okay, you can draw this arrow across here. A number increased by 3, 4 plus 3 is 7. And then we take a number, 8 increased by 3, and then we get 11. Okay? Now you'll notice that at no time did I look for the pattern downwards. Because sometimes when you look at patterns going down, it all relies on the pattern in this column. So if I break the pattern, in this column we've gone up by 1. We start at 0, 1, 2, 3, 4. But then if I break the pattern and jump up to 8, that's going to break the pattern in this column. So that's why we always have to look across. We always have to ask ourselves this question in yellow. What do we do to N to get A? So I want you to get that old strategy of looking at the pattern between these numbers. I want you to just get rid of that idea. Okay? All right, the last part. Write a linear relation as an algebraic expression. Okay, so in other words, what we're doing is we're taking this rule in words and we're translating it into an algebraic expression. Now before, when we did algebraic expressions, we used a variety of letters, but mostly we used X. But for these type of questions, it's kind of standard to use N. Okay, so N stands for a number. So the algebraic expression here is n plus 3. So we've completed this entire question. So we've actually used a lot of skills, but a lot of skills that are related to each other. First, we had to determine the strategy by looking at the value table. Then we wrote the rule in words. Then we completed the value table, and then we wrote the rule as an algebraic expression. Okay, so a lot of steps there. Okay, let's go on to example 2. So again, we look at the question. The strategy is, what do we do to x to get y? So in this case, you notice that the column headings are now x and y instead of n and a. Now, n and a are kind of the standard column headings for this type of question, but again, we can also use x and y because this is going to be important when we get to the next step of graphing these relations. Okay, so let's look at an x value. The first one, 10, and then it becomes 4. So automatically, I hope you're thinking, okay, then this can't be addition because we can't really add anything to x, 10, to make it a smaller number, 4. So what do you think? Again, look at the clue, look at the section that we're in. So what do you think we did to x to get y? So if you've got an idea in your head, then I need you to check it for this row as well. What did you do to 13 to get 7? It has to be the same rule as the row above. And if that rule works, does it work for if you start with 20 and then end up with 14? Okay, so what do you think the strategy here is? So hopefully you're thinking. Of subtracting 6. Okay, so if you think that that's what your rule is, let's go in and check our values. All right, so if we have an x value and we subtract 6, 10 subtract 6, does it equal 4? Yes, it does. 13 subtract 6, does it equal 7? Yes, it does. 20 subtract 14, 20 subtract 6, does it equal 14? Yes, it does. So now I know that this rule or this strategy works. Okay, so now that I've proven that that strategy works, how would I describe the rule in words? Okay, so how about a number? And do you think you can finish this rule in words? So there are a number of possible answers here. So I can put a number decreased by 6. I could have put a number subtract 6. I could have put the difference between a number and 6. Any of those would have been fine. Okay, so now that I know the rule in words, let's go back to the value table and figure out the rest of them. So 25 is a number decreased by 6. Okay, so what did you get? Actually, why don't you go in and fill all the rest of these in? Okay, so I hope you got these values for y. I got 19, 25, and 42. So in order to calculate those, remember at no time did I look down the column like this. I always went across. Okay? All right, the last step. Write the linear relation as an algebraic expression. So I need you to translate this statement in words into an algebraic expression using the letter n. Actually, in this case, we can use the letter x, can't we? Because x is this column right here. So let's do that. Now it wouldn't be wrong if you used n. Actually, that's a terrible x. Let me erase that. All right, so how about we have x subtract 6. A number decreased by 6. Okay, so we've now figured out all of the sections of this particular question. Okay, so this ends the first part of this video tutorial on strategies to find linear relations note. Thanks for watching. Bye.